Hi everyone, welcome back to another video. So I'm a second year electrical engineering student in the UK, and I'm now starting to really in detail plan my final year project. So final year being my third year in university. And so I'm thinking to go for something in the renewable energy power generation side of things. And so I've got quite a few ideas, and I'm now discussing with my supervisor some of the ideas that I want to go ahead and actually start doing. And so he's asked me to present him some of my ideas. And most of the stuff that I have is kind of a scattered brain approach. And so what I'm doing now is I'm going into a lot more detail on some of my ideas, and I'm actually coming up with in-depth ways in which my final year project could evolve. So this is one of them. It's the Renewable Energy Educational Kit. The idea is that it's like a Raspberry Pi with a whole bunch of other like DIY things around it, kits, circuits, solar panels, wind turbines, etc. So that's the idea of it. So we're going to be going through it in this video. The purpose of this is basically just to let you guys know where my head's at in terms of my final year project planning. And then I'm going to do a few more of these videos for some of my other ideas as well. So at the moment, this is the only idea that I've done where I've gone into this much detail. So let's get straight into it. So the kit itself is based around the Raspberry Pi 4. You've obviously got the 2 gig version, the 4 gig version, and the 8 gig version. I'm assuming that I can do everything I need to do since I'm not actually going to be using the OS, the operating system of the Raspberry Pi. So 2 gig version should be good enough. And to be honest, probably could do it on a even cheaper Raspberry Pi, maybe the Raspberry Pi Model B or something like that. So yeah, the Raspberry Pi 2 gig should be more than good enough. So that's going to be the brain and the center of the kit. So let's take a look at what we've got inside the kit. So we're going to have, basically the idea is to have some prototype boards, which are these like perf board things that you see here. And then we're going to have, schematics of the various different circuits that we're going to be doing. We're going to have a whole bunch of bags of little components that you're going to need to build all of those circuits from the schematics. And then a tutorial that students, users, hobbyists can use to follow along and build each circuit bit by bit. And then the plan would be obviously to make PDF tutorials first of all, and then make video tutorials afterwards as well. So let's talk a little bit about the tutorials. So the tutorials would explain how the student can build a variety of the different circuits. So it'll be like in an ebook PDF format, and all of those circuits would relate to renewable energy that will interface directly with the Raspberry Pi. So each tutorial would go into detail about the principles behind each circuit. So what, for example, a battery management circuit, a BMS circuit is, how it operates, and then go into really in-depth detail about what components we're using to build each one of those circuits. So the idea would be that for me, as a student, I'll be learning for the first time how to build these circuits, right? And then by me actually detailing tutorials on how the circuit's functioning, by creating block diagrams, by talking about what each component is doing, why I'm choosing 470 microfarad capacitor versus this, why I'm using a 400 ohm resistor here, whatever. You know what I mean? Really going into detail as to why I'm using each component. That will mean that I'll obviously learn in detail, what we're doing. And it also means that students can either just go and build the circuit based on my instructions, and if they want to know a lot more detail, or if they want to fix something, change something, they can, because I've gone into that much detail about what it is that we're doing on each one of the circuits. So that's the plan with the tutorials. And then with each circuit that the student builds, we're going to take the data. So for example, if it's a wind turbine, how much energy that wind turbine is generating, then we're going to take that data, put it onto the Raspberry Pi, and then send it off to the cloud. So it can be accessed either via a web interface or via an Android app or something like that. So this is obviously going to be quite tricky, and it makes my project a lot more, difficult than it needs to be. I could just exclude this part. However, I'm super interested, excited, whatever the word you want to use is, to do things like apps and stuff like that. Not because I'm not interested at all in getting into app development, not interested in working in software. I'm not at all. However, for my own personal uses, I'm super interested in apps. Like, if I can run everything using apps, I would. And so, I've got a lot of ideas of stuff that I can do, not for businesses, more so for helping different like things out, helping friends out, helping some communities out with certain apps. I've got a lot of good app ideas, and so I would like my final year project to involve an app, even though it makes it a lot more difficult. And I actually have like no experience developing apps, right? I've never developed an app before. However, it's something that I want to do, not because I want to work in that field, but because I want to use apps and app development in my actual physical life. So that's the plan. I'd like to include apps into the final year project, even though it's not per se necessary. But let's take a look at some of the circuits that will be inside this kit. So first and foremost, we're going to have a solar panel, and then we're going to have like a charge controller, solar panel, and something that will charge the battery. So you can see here, you've got this little circuit here. So what we'd do is, for example, we'd have just a plain perf board or a PCB, and then we'd have each one of these components there, the different connectors, the IC chips, the resistors, transistors, etc. And we'll talk through the student on how to actually build that circuit themselves while we're using X, Y, and Z components. And then this would obviously, the solar panel would just be included in the kit, just as is bought from China. And then that solar panel would obviously generate electricity and use it to charge, for example, like a LiPo battery. So you would have, this would be one standalone circuit kit by itself, just creating the charge controller and the circuitry needed for the solar panel to charge the battery, and also for the Raspberry Pi to run off of the power from the battery and the solar panel. And it's actually quite, if the Raspberry Pi you don't want the Raspberry Pi obviously running from the solar panel, because at any moment, cloud, etc. So you want kind of like some circuitry in this thing that the Raspberry Pi could run off of as well. So that's quite fascinating to me. And so that would be great for me to learn personally, and then also to turn that into tutorial. So this would be like the first tutorial circuit, so to speak. All right, so next up, we've got an energy monitoring circuit. So probably a bit more complex, but the idea would be to have like some sort of Wi-Fi module, and you would have to have, probably some sort of voltage sensors and current sensors, and determine how much energy the solar panel or, for example, the wind turbine or whatever would be generating, convert that, using some calculations, using a voltage divider. So it's going to be some fairly complex maths involved here. But it would be probably a very interesting, fun project. Would involve obviously designing the circuits to sense. Obviously, you could just use a voltmeter, but to make it a lot more interesting, it'd be cool if the student, for example, imagine like a 17-year-old, he'd build like a little voltmeter, basically, using a voltage divider or something, connect that to, the output of the solar panel, and then have that connected to a Wi-Fi module, or even probably the Wi-Fi on the Raspberry Pi, and then have that going to an IoT service. So that would be quite a cool circuit. Then you've got energy storage within batteries, which is obviously really cool. So if you can get the Raspberry Pi to run off of the battery, whilst also getting the solar panel to charge the battery, and then having a way to monitor the battery voltage, and also, time until charge, time left, for example, if you're running it at night time purely off of the battery with nothing going in from the solar panel, telling you how much charge you've got left, all that kind of stuff. So that whole circuitry there, the BMS system, the charge controller to charge the battery, all of that kind of circuitry, that would be interesting. And you can tell, I mean, by the way that I'm speaking about it, you can tell that I don't know what I'm talking about, really. I've watched some YouTube videos on this kind of stuff, but as for the intricate details, right now as a second year electrical engineering student, I don't know any of this stuff, none of it. And so it's fascinating to me that, this would be a great project for me, that I get to build all of these individual circuits and then create tutorials for them, for other people like me that are just learning to build it. So that whole thing there is just exciting, proper exciting for me. So next up, we've got the voltage and current sensing, which I kind of alluded to already in terms of the energy IoT system. But yeah, so basically designing a little mini multimeter kind of system. You can see here they've got some probes connected to is that a Raspberry Pi? It looks like, yeah, that's a Raspberry Pi, isn't it? Yeah. I just got the picture of Google. But yeah, coming up with a voltage and current sensing circuit. So I actually I know how to do this easily using the Arduino modules, but it'd be cool to actually build the module itself, the circuitry itself on a perf board using, normal size resistors and stuff like that. That I'm really into that. So yeah. Next up, we've got wind power generation, which is probably the most fun one for me. Although I'm not really interested in wind energy, it's exciting to me to, 3D print a wind turbine which I'll show you later on. In a couple of minutes time, you'll see you can really print some amazing wind turbines. So it'd be cool if I included CAD files, which is computer aided design files, for someone who has a 3D printer to print their own wind turbine, basically, and then see how much power it can generate. That whole thing there was just exciting to me. And so, for example, I can have one kit whereby it includes a wind turbine and another one where it doesn't include one. Or you could have, for example, it has, for example, a small scale wind turbine, and then you could also include some CAD design files inside the tutorials, whereby the person could actually go and print their own much bigger, larger, more powerful wind turbine. So yeah, that's all exciting to me. And once the person's built all of the individual projects, the idea would be to put the whole project together into one kind of small microgrid project, in which the Raspberry Pi runs on the battery. The batteries are charged using the solar and the wind power. The current and voltage sensing circuits relay the circuit's performance to an IoT connected energy monitoring kind of device, which streams all of that data onto a web service and an app. So yeah, that whole kind of, if you can imagine like a 17-year-old having, their parent buys this kit. Let's say the kit's £100 or something. £100. The teenager takes, let's say 6 weeks of his time to go through it step by step. Imagine what they would learn at the end of that. That excites me. And the fact that I could work on a project that could help motivate and pump up some people to get into renewable energy, it's just cool. That idea, I just love it. And, the fact that I could give this kit to my kids and go on and let's do this together, that just, brings a big, big smile to my face. All right, so as I mentioned, 3D printing. Look here, man. All of these wind turbines 3D printed. Look at that. Amazing. Honestly, absolutely amazing technology. But yeah, so just basically thinking about including CAD files for people to be able to print their own turbine. And then so let's talk about the business model, which obviously as a second year and a final year electrical engineering student, I'm not too interested in the business model side of things. Obviously, I'm not looking to sell it at all. And I'm actually thinking to kind of, obviously, if I document the whole process of my final year project, then technically, and it's obviously the case that anyone could just take and steal all of my work. And I'm fine with that. I like the idea of keeping things open source. I mean, to be honest, Arduino are open source, right? And they're doing well. So yeah, I'm not too bothered about people stealing anything, but I like this Elegoo model that they have, whereby, for example, they're using the Arduino Uno R3, but they've just got their own one, right? Since Arduino is open source, so they've got a basic starter kit here, which, as you can see, has the Arduino Uno, a small breadboard, literally the small breadboard, some resistors, some LEDs, some buttons. Can't see what else is there, but I actually have this kit myself, a buzzer. And so the tutorials that they include like 5 or 6 tutorials, maybe 7. And I've actually done this whole playlist on my channel. So yeah, they include that, and it's whatever, £12, £13 for this kit. Then if you get the slightly larger kit, it includes a bit more stuff. You can see, the extra wires, the motor, the servo motor, etc., LCD screen, and so a little expansion board. So they include a bit more, and then also the tutorials that come with it are like an extra 10 circuits, for example. So that's so you got, let's say you got 7 tutorials, then you got 17, and then the larger one, $58, $59 includes all of their tutorials. So you got like 30, 40 tutorials, and they actually have like some advanced tutorials where you're mixing and matching different projects. So that business model appeals to me a lot. So for example, I could just make this basic starter kit myself after my, in my third year, have the basic starter kit as my final year project, and then I could expand on it later on, have a super starter kit, and then expand on it later on and have a most complete starter kit. So that all excites me. So you can, if you imagine, you can have, for example, a £50 kit with no wind turbine. You could have, for example, a £70 kit with a wind turbine, and you can have, a £100 kit with a wind turbine plus, a frame, for a solar tracker, and to develop, a solar irrigation plant watering system with a whole bunch of like 10 other different projects. I mean, technically it's limitless and endless, right? So I love it. That's very exciting to me. So let's talk about target audience. I kind of already alluded to it, but the target audience would be young adults and hobbyists. So obviously you need like someone who's competent with a soldering iron, not going to burn themselves. So I'm not trying to make it, those kits that you can get where it's like magnetic and you just kind of like, it's for like maybe like 8-9-year-olds, where it kind of works and kind of isn't really useful, but it's supposed to teach them. It's for like, young. I'm not looking to do that. I'm looking to do proper circuits that, hobbyists, YouTubers, whoever can go buy it and actually use it and create, like actually create a battery management circuit, etc. So yeah, so it's for young people, young adults, hobbyists who can actually take my code, alter it, for example, all of that kind of stuff. So that's the plan with the target audience. The plan for the overall project, which, I'm sure if my supervisor is watching this, he's going to be like, what the hell, this is way too much. And it is a lot, of course, especially to do in like 6-7 months. But my hope is to do it in a year, because if I start now and I've got to submit it in a year's time, then I could do it in a year, I think. But the plan is to basically take one circuit. So for example, if we go and we just take the energy storage within batteries and just build this whole entire, talking about create the schematic, gather the components, make the tutorials, PDF tutorials, video tutorials, have the whole thing done of just a Raspberry Pi energy storage within batteries tutorial kit. That's it, just one kit. And thereafter, go one by one and add all of the other kits on individually. So obviously my main concern is that I don't want to have six half completed circuits, right? I want to have, if I run out of time and I get to, April and I haven't completed, the solar panel project, let's say I get stuck on something, I'm not able to get a part, whatever, at least I have 2 completed circuits, and then I can still submit my final year project, having, failed at the other 4, for example. So that's the plan. Basically, do one project, one little circuit at a time, and then expand as I go on. Whenever you do these kind of things, you obviously want to research what's on the market already. And it's difficult because obviously we live in, it's 2021. Arduinos have been out for a long, 10, 12, I don't even know how many years, a long time, right? So there's a lot of stuff that already just exists, and it's very hard to be unique. However, saying that, it seems like this is super unique in the sense that I've looked for what are the best examples of this type of kit that I could find, and literally there's nothing. Probably the Horizon one comes closest, but other than that, nothing. So let's just go through what I found available. These are what I consider the closest to what I'm trying to achieve, but literally none of these are what I'm trying to achieve. So let's just go through them anyways. We'll start with the Arduino Opela IoT starter kit. So it's £107. It's supposed to be a device that allows you to add, for example, like different Internet of Thing projects to this one thing, and it's got like touch buttons on the side. I don't really get the point of it. For £107 seems like a lot. Like, I don't think any hobbyist or anybody's buying this. Maybe some rich YouTuber, I don't know, but it seems like a lot for £107. But yeah, anyways, that's an Opela IoT starter kit. I kind of just like the packaging of the whole thing. So yeah, I thought I'd include it. So here we've got the Elegoo Uno R3 Most Complete Starter Kit, which is what I referenced. And as you can see, I took this screenshot on Amazon. And you last purchased this product, this item on the 22nd of December 2020. So I actually own this. I paid £51 for it. And it's an amazing kit. It's not what I want, because obviously I'm trying to do the Raspberry Pi, I'm trying to do renewable energy. There's nothing here renewable. You're not DIY building any circuits yourself. You're just using these cheap modules that you can buy off of eBay and stuff like that. So it's not what I'm trying to do. Probably the best way to put it. It's definitely not what I'm trying to do. However, this is a really good kit, and my idea would be to try and make a kit kind of like this. So here, this is probably the closest to what I'm trying to do, but not really. It's £165. There's a lot. The Horizon FCJJ37 Renewable Energy Education Set. So interestingly, they actually include like hydrogen and fuel cell stuff, which I found very interesting. I'm not convinced that I want to start messing about with hydrogen and fuel cell stuff. So I kind of just left it out of this whole kind of kit. As the renewable energy side of things, I just kind of ignored. Obviously, I'm not trying to do any thermal energy stuff as well. So, but this kit is a bit funny because it's kind of like it's like, it would be like if Apple made a kit. It's just like it's a well designed, nice kit, but it's a bit kind of like childish. Seems like it's for like, possibly like 8-year-olds. You just kind of connect things together. Definitely not really what I'm trying to achieve or anything, but this would probably be the closest to what I'm trying to do. Here we've got the Kittronics Inventors kit for the Arduino. I like they have like video tutorials of these. Check it out on YouTube. They got a good YouTube channel with like 5K subscribers. It's £20 kit. I like the kit. It's they got like a little this is not really a wind turbine, is it? It's more of a motor with a fan on the end. But it's nice, they give you a proper little booklet, which I would love to do, print an actual physical booklet, ship that with the kit. That'd be amazing. This is an Arduino kit. I like it. Check it out. Really high quality, really attention to detail, on a plate. I love it. It's a very, very good looking, aesthetically pleasing kit. And yeah, although this is not what I'm trying to do, it's this. I draw a lot of. I think I've drawn a lot of inspiration from this kit, so I like this kit. So we've got the official Arduino Student Kit. I think this is crazy how much they're charging for this, 54 euros. It says learn the basics of programming coding. There's not much to this. It's an Arduino Uno R3, which is like £15. They give you a 9-volt battery, a small amount of components, and a multimeter. Yeah, I'm not convinced by this kit. I just like the fact that it came with like this little plastic box Tupperware thing, which I thought was cool. And maybe I could, if I make my kit, I could maybe ship mine in that or something. So that seems like I like the aesthetics of this, but the kit itself, bloody hell, man, 54 quid. This kit was a bit strange. It's a rapid educational solar energy kit. You basically kind of build your own solar panel, which is not really what I'm trying to do, because I'm not really trying to get people into the manufacturing of, solar panels, stuff like that. Like, people aren't really going to do that, are you? I'm more interested in the energy generation side of things, which, yeah, I thought this would be like a cool concept, and I liked the way that you actually build it. They give you like some like very basic mechanical tools, kind of like what you'd get in like if you build an IKEA wardrobe or something. I liked what they included in the kit, so I put it here. It's £13. Again, just to kind of take inspiration from it. This one I really like, the Totem Mini Lab. Look at it. It looks beautiful, from Pi Moroni. £90, which is obviously a lot. I don't know what this is. This looks like I don't even know. I don't know what it is. But I just imagined, for example, having a Raspberry Pi underneath here, and then having a circuit that you build, putting it up there, connecting it. I would love it, absolutely love it, if my project at the end looked like something like this. Just looks amazing. Look at it. So yeah, again, to kind of draw inspiration from, and that's about it really. So where am I at? Obviously, I'm undecided. This is the first of, I've got like 50 ideas of stuff that I want to do, and so when I'm looking at each idea on a surface level, it's super confusing to try and figure out what I want to do. And so I'm gonna go in detail into a bunch of different ideas until I'm just like, nah, you know what? I'm gonna go back and do that one. That one excites me. And this idea of making a renewable energy kit, it bloody excites me. I'm well excited. So, the amount that I would have to learn to pull this off is crazy. To learn this in a year is crazy, absolutely crazy. And I'm a crazy bugger, so I think I'm up for it. I think I'm going to do it. I really think I'm going to do it. And for now, just for the sake of keeping my options open, and because I would really love to do, like I would love to do a commercial scale, industrial product or something that could be used in like Africa and Asia and South America to give people power. Like, I would love to do that. I would sleep so well at night, so well, if I could have something like that. And so that's the only thing that's stopping me from just pulling the trigger on this idea and saying, you know what, let's just make this renewable energy kit, because the renewable energy kit is for privileged kids, right? It's for kids who are either going to a school whereby the school has the money to be buying these £100 kits off of me or whatever, off of Amazon, or a hobbyist who has the money to be paying. Like, many hobbyists, the way that they get into electronics is they, like, their mum's electronics breaks and they open it up and just start fixing it and messing about and sticking their screwdrivers into capacitors. But for people like me and maybe you, we go and buy expensive oscilloscopes and Arduino kits and stuff like that. So, it's nice to get people into renewable energy and stuff like that. But it's not as fulfilling, rewarding for me as it would be to make a product or a unit, something that could be used to generate electricity, in somewhere like Africa. That excites me a lot. So yeah, I'm still going to carry on planning, still going to carry on coming up with other ideas, but this one is a very exciting one. And yeah, thanks for watching, guys. I shall see you guys around.